Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome you all the student of class 11 for our chemistry lecture. As we have started the chapter elements of group 13, 14 and 15. This is our third lecture for the same. In our previous lecture, we have studied trends in atomic and physical properties of elements of group 13. Today, in this lecture, we are moving forward towards trends in atomic and physical properties of elements of group 14 and 15. In our previous lecture, we have studied two numericals. Today, we are going to study more numericals for the same. So, let's start, student. We are going to study table 9.3, which states, which explain atomic and physical properties of the elements of carbon family. What is carbon family? Carbon family is nothing but it is group 14. In these groups, all the three traditional types of elements are present. What do you mean by traditional types of elements? All the three, that is your metal, non-metal and metalloids. So your student, carbon is a non-metal. Carbon having a properties of non-metal, it is a non-metal, while silicon is a metalloid, which is brittle like non-metal. So here in this group, that is a group 14, that is a carbon family, all the three traditional type of elements are present, that is a metal, non-metal and metalloid, in which carbon is a non-metal, silicon is a metalloid which is brittle like non-metal. It is hard and has metallic luster. Metalloid means which is having an intermediate properties between non-metal and metal. While germanium is also brittle but hard and lustrous metalloids. A silicon and germanium is a metalloid, while carbon is a non-metal. Tin or lead down the group are corrosion resistant and moderately reactive. Okay. So here student, there are 5 members in the group 14, that is a carbon, silicon, germanium, tin and lead. So we have studied this thing in detail in our previous lecture, which are the elements are present in the group 14, that is a carbon family. There is carbon, silicon, germanium, tin and lead, in which carbon is a non-metal, silicon is a metalloid, germanium is a metalloid, tin or lead are corrosion resistant and moderately reactive. Okay, so here student, this is the table, that is 9.3, which states physical and atomic properties of group 14 and elements. You're supposed, in a previous lecture I have stated, only you're supposed to know that whether the atomic radius and ionic ionization enthalpy electron negativity is increasing or decreasing down the group. You're not supposed to study the value, only you are supposed to study whether it is increasing or decreasing. So here in group 14, there are 5 members, that is your carbon, silicon, germanium, tin and lead. The atomic numbers down the group, it is increasing. For carbon it is 6, for silicon it is 14, germanium 32, for tin it is 50 and lead it is 82. As the atomic number is increasing, see the table for atomic number, it is increasing down the group. Then the next to atomic number, atomic mass is there. As atomic number is increasing, atomic mass will also be in increases. So atomic mass is increasing down the group. Then next to atomic mass, atomic radius is there. So see the value, that is 77 to 118 to 122 to 140, 146. So what do you observe, your student, that the atomic radius is also being increases. What is atomic radius? It is nothing but the distance from the nucleus to the outermost shell of an atom. Okay. Then we are moving towards ionic radii. Here the value is been given for M3 plus. M3 plus means when it gives an electron. So here the value for carbon has not been given. Why? Because carbon is a non-metal. Okay. Carbon doesn't give it electron. Okay. So here ionic radii for M3 plus has been given. You see, what do you mean by ionic radii? The ionic radii is nothing but it is the distance from the nucleus to the outermost shell of an iron. Okay, so here the these all things, this all definition we have studied in chapter number 7 in detail. So here in the group, ionic radii is also being increases from moving towards carbon to lead. Then ionization enthalpy. What is ionization enthalpy? It is the amount of energy required to liberate the most loosely bonded electron from an isolated gaseous atom. As we know, atomic radius will increases, the distance from the nucleus to the outermost shell will increases. As the distance increases, the bonding between the nucleus to the outermost electron will decreases, so we can easily remove the outermost electron, that is the last electron, from an isolated gaseous atom. So as we know that the atomic radius is increasing down the group, so ionization enthalpy value will decreases down the group. So you see that from the value, first ionization enthalpy to remove the last electron, second ionization enthalpy means the amount of energy required to remove the second last electron, third ionization enthalpy means the amount of energy required to remove the third last electron, fourth ionization enthalpy means the amount of energy required to remove the fourth last electron from an isolated gaseous atom. So as we know the atomic radius is increases, ionization enthalpy will decreases down the group. Similarly, electronegativity, see the value for electronegativity, it is also being decreases down the group. So then we are moving towards density. As the atomic mass is increases down the group, density will also be increases down the group. Metal melting point, it is being decreases down the group. Boiling point, it is also being decreases down the group. So here these is some of the physical and atomic properties of the elements of group 14. We are moving forwards towards group 15. Trends in atomic and physical properties of elements of group 15. Group 15 is the nitrogen family. We are going to study table 9.4, which show atomic and physical properties of the elements of group 15. In these groups, we are going to see all the three traditional type of element, that is a metal, non-metal and metalloids. Here as that we have seen in group 14. The gases nitrogen and brittle phosphorus are non-metal. They are the first two elements, nitrogen and phosphorus, they are non-metal, while arsenic and bismuth are metalloid. Arsenic and antimony are metalloid and bismuth is metal. So all the three types of traditional types of elements is being present in group 15, in which nitrogen and phosphorus are non-metals, arsenic and antimony are metalloids, while bismuth is metal. We are supposed to know. First, the first two elements are non-metal, then the other two elements are metalloid, and the last element is your metal. So here student, group 15 is nothing but your nitrogen family, in which five elements are present. In that, nitrogen and phosphorus is non-metal, arsenic and antimony are metalloid, while bismuth is metal. This is the table which state the physical and atomic properties of group 15 elements. So yeah, group 15 is your nitrogen family, in which five elements are present: nitrogen, phosphorus, arsenic, antimony and bismuth. The atomic number for nitrogen is 7, for phosphorus is 15, for arsenic it is 33, for antimony it is 51, and for bismuth it is 83. As we know, as we are moving down the group, as the atomic number is increasing, its atomic mass is also being increases. You see the Table for atomic mass. It is being increases down the group. As the atomic number is increasing, numbers of electron is being increases. As the number of electron is increases, its shell is increases, and its shell is increases, the distance from the nucleus to the outermost shell of an atom is increases, so atomic radius is increasing down the group. While ionic radii is also being increasing down the group till nitrogen to arsenic. You see the table for ionic radii. 171 for nitrogen, for phosphorus it is 212, for arsenic it is 222. So it is being increasing down the group. And then for antimony it is being decreasing. For bismuth further it is being increases. Okay, it is due to the liberation of an electron from the gaseous atom. Okay, then ionization enthalpy, as we know, if atomic radius is being increases, atomic radius is inversely proportional to the ionization enthalpy. Atomic radius will increases, ionization enthalpy will decreases. So as the atomic radius is being increasing down the group, so ionization enthalpy is being decreases down the group. Okay, so here for nitrogen family, ionization enthalpy is being decreasing down the group. Electronegativity. Electronegativity is also inversely proportional to atomic radius. So here in nitrogen family, atomic radius is increasing down the group. So electronegativity will decreases down the group. Then density is directly proportional to atomic radius and atomic mass. As atomic mass and atomic radius is increasing down the group, density is also being increases down the group. Okay, so then we are moving towards melting point and boiling point. We see a variation in melting point. It is first increasing till arsenic and then it is being decreases. Similar for a boiling point, it is being increasing and decreasing down the group. So these are some of the physical and atomic properties of group 15 elements. In this way you are supposed to study. So if the question will arises like that, what give the trends of atomic radius of group 15 elements? So you are supposed to state that in group 15 element, that is your nitrogen family, as we are moving down the group means as we are moving from nitrogen to phosphorus to arsenic to antimony to bismuth, the atomic radius is being decreases as that it is being increases. As the atomic number is increases, its atomic radius is also being increases. Okay, if the question arises for ionization enthalpy, you are supposed to state as down the group atomic number is increasing and atomic radius is also being increases down the group. As atomic radius being inversely proportional to ionization enthalpy. Ionization enthalpy is nothing but it is the amount of energy required to liberate the most loosely bonded electron from an isolated gaseous atom. As the distance from the nucleus to the outermost shell is increases, we can easily remove an electron from an isolated gaseous atom. So atomic radius is being increases down the group, which is inversely proportional to ionization enthalpy. Hence ionization enthalpy will decreases down the group. In this way you are supposed to answer, student. Hope you all have understood it well. Study well, student. Till then, take care. Allah Hafiz. Thank you.